All right, so we got Advent of Code 2024, day 3. And this one is called Mull It Over. Our computers are having issues, so I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though, says the mildly flustered shopkeeper at the North Pole Toboggan rental shop. Well, that's from 2020, day 2. Okay, so this is what the history is being all about. We're hitting, because in day 1 we hit a 2015 callback, and now we got a 2020 callback. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computer appears to be trying to run a program, but its memory, your puzzle input, is corrupted. All of the instructions have been jumbled up. Oh, good. Last year we didn't get any VMs, so maybe this will be a VM puzzle? I was a little sad about last year not having any VMs, because I like those puzzles. It seems like the goal of the program is just to multiply some numbers. It does that with the instructions like mul xy, where x and y are each 1 to 3 digit numbers. Oh. For instance, mul 4446 multiplies 44 by 46 to get a result of 2024. Similarly, mul 1234 would multiply by 123 by 4. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of a mul instruction. Sequences like mul open 4 star, mul open 6, 9 bang, question mark open 1234, or this. Oh, so spaces get ignored. Okay, I mean don't get ignored. Spaces are significant. Consider the following section of corrupted memory. Okay, only the 4 highlighted sections are real mul instructions. Adding up the result of each instruction produces 161. All right. I think we can do this. Get input, 2024, day 3. Whoa. All right, so this is 6 lines. And each line is pretty long. Okay. Does it wrap? I see the end of this string doesn't. I was just wondering if maybe we had to meld them together somehow. But it looks like it's all good. Looks like it's all good. Okay, so we get 6 lines. So let's start up with setting this thing up. Okay, and then we'll create the module. We'll jump to it. Oops. This is 2024, day 3. And then we should get unsolved, and we do. Okay, so we can write a little function. I'm just trying to anticipate what might happen for part 2. I wonder if we have like nested multiplication, so you do mul, blah, blah, blah. But I think what we can do is for each line, we'll just look for mul open, then we'll split on the comma, and then we can split on the close paren, and then parse these guys. That should be the most straightforward way to do it. Maybe. We'll see, lines is going to be a vec of string. We're going to say self lines equal to AOC lib, read lines, input 2024-03.text. That compiles. Let's just print out, we should have 6 lines. Self lines len. We do have 6. I'm just looking over here for the answer. So let's write a little function. If we scan a line and look for a mul, and then call another function which does the mul, maybe we can do it that way. Break it into 2 pieces. So let's start actually writing a test for that. Test mul. And we just want to see if we can multiply 25. We should be say multiply and just give it a string of mul 55. and then write a function called multiply, which takes a string and returns a usize. Ooh, are there negatives? Maybe there's negatives. It doesn't specify. It says 1 to 3 digits. So I'm going to assume there's no negatives. So actually what we can do is we can pass it, we can be a little simpler and just pass it this bit. And then just have, and the rest here, because we'll do a split. So 0. Let's hit test. That should fail, right? So now what we can do is say let left is equal to, no, left rest is equal to est split once on a comma. Unwrap. Oh, we might not. Okay. I was just thinking that's interesting because there might not be a comma. Right? I'm looking for a string that goes mull xy, but it could be mull 1 2 semicolon 3 4. So there might not be a comma. So let's do this. If let sum else, and then we'll make this an option usize. That way we can handle problems. Else return none. And now left should be the number. And so we should be able to actually get it. Not if, let, just let, semicolon. Okay, so now we get the number. And we'll do the same thing. Let sum left is equal to left parse usize. Else return none, right? Semicolon. Let me put none here so that that warning goes away. Oh, this is okay. All right, there we go. So we parsed left. Now we just need to, so the rest should have everything after the comma. So we should be able to say let sum right is equal to rest split once on close paren, else return none. And then we just say return sum left times right. Oh, I forgot the semi. And this should be sum 25. Oh, I forgot to parse it. Oops. Oops. Right. And right. Okay, that worked. Let's test to make sure that some other things return none. So 5 semicolon 5 should return none. And 5 comma 5x should return none. Good. All right, so we have multiplication. Now we need to just loop over the string. So fn process. We're going to look over the whole string and return. This one's going to return a usize because it could end up being 0. Alka says you can also replace the else return none with a question mark. Oh, that's a good point. That's a good point. That simplifies the code even more. We can just do this. Oh. And that simplifies this, right? And then we can do that for all of them. Because I think it can transpose the OK into an option as well. Oh, no, you have to say something else here. What do you say here? Something transposes this to an option, right? There we go. Error. OK. Like that. Yeah. Okay. So we do this. I like it. Does the test still work? Test still passes. Good. Okay, so now we're going to start off at position 0. We're going to find while let some location is equal to s of pos dot dot starts with mull. Then we're going to add, or we're going to find out if we can add let value equals multiply. We're going to say pos plus equals 4 multiply s pos dot dot else continue, and then we're going to have a total. Let total total equals 0, and then total plus equals value, and then we return total here. Oh, forgot that. And what did I miss here? Continue outside of a loop. Oh no, that was right. What did I do wrong here? Expected bool found option. Oh no, I don't want start, so I want find. Right? And that returns an option you saw. Yeah. And we can't do total plus equals value because value is an option you size. There we go. Oh, pos plus equals lock. Plus 4. No. Right, we want to skip forward to that position. Yeah, and then plus 4 to skip past the mull. Right, got it. And process is not called. Let's process this line here. You hope they lift the restriction soon. Okay. Test line. So now we get the whole line here, and it should be equal to 161. Okay, so assert EQ bang 161. Process this line. Yeah, it worked. First try. Okay, so now we should be able to do this here. We should be able to say self lines iter map process sum. I probably have to tell it usize, right? Oh, what is it expecting? Oh, expected string. That's a shame. Because it's Clippy's going to complain to me if I put string here. Oh, and now I can't do this anymore. Right. How can I do this like s as ref stir? I think I can get away with that. S dot as ref. Okay, so test run. And we got this as our answer. Should we try it? Yay, that's the right answer. Okay, let's check in with Clippy. And I think we're good. That was pretty straightforward. I like that one. Get status, get add source, get diff staged. Yep, so it's just part 1 and then that stuff. Okay, get commit -m 2024 day 3 part 1. Oh, I didn't want main. I wanted 2403. There we go. Okay, so let's see what part 2 is. As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. There are 2 new instructions you'll need to handle. Do enables future Mull instructions, and don't disables future Mull instructions. Okay. Only the most recent do or don't instruction applies. Excuse me. Applies. At the beginning of the program, Mull instructions are enabled. Okay. So we have a new example here, which has a don't and a do. And we're still summing up all the multiplications, but just the enabled ones. Okay, so let's write another test here. Test conditional. So we're going to assert equal that 48 is equal to process conditional of this. And process conditional does not exist, so let's write it. It's going to be the same function signature. I should put it after, right? Because it's part 1, then part 2. It's essentially the same code, except we're going to find whatever the next thing is. So let's write a little function which does that. We can pass in get next, we'll call it. Oops. And it'll return the next thing to do. Either a do, a don't, or a mull. And the location. Okay, enum that we skip to. Enum instruction. And it's going to be a mull, a do, or a don't. And so this is going to return an instruction and a usize. For the this will be the offset of what we found. So what we'll do is we just need to find out which one is next, and it could be mull, do, or don't. So let's say let mull location is equal to s.find mull, and that's going to give us an option. And then we'll have a do location and a don't location. Like that. And each one of these is going to be options. Now we want to return the smallest, the one that's smallest. And which one it is. We can get the smallest this way. Iter, filter map, lock, star lock, min. Oh yeah, that's true. What we want to do is put an option usize, because there might be not be another one. And then how do we know which one it is? We don't. Let's start off just by returning what it is. Okay, let's switch over to test again so we can see the test fail. Okay, so we do have the length. We can say while, so let mot pause equals 0. So it follows a similar kind of structure here. Let total equals 0. while let sum lock is equal to, but now we're going to say get next on s of pos, s as ref, pos. And that'll give us the new offset. And then we can check. Then we can check if it's a do or a don't or a mull. We can just check the first two characters, I guess. Can I say that? Match s as, let's do this. Let s equals s as ref. Can I do that? And get rid of this. S of pos dot dot pos plus 2. If it's a mu, then it's a multiply. And we'll say let product equals multiply s of pos plus 4. And then, oh, we have to check to see if we're actually, oh, we need more than 2. We need 3. It's mull. It's going to be do open paren. Let mut enabled equals true. They said they start with enabled is true. So then this is just enabled is true. And if it's don, then it's enabled equals false. We do want to move past this. So pos plus equals 1. Actually, the smallest is 4, so we can skip past 4. Okay, and then we can say if enabled, then do this, and then total plus equals product. Oh, it might not exist. If let sum product is this, then total plus equals product. And another one of those. Oops. Mismatched terms. Oh, I left these in. Oops. Oh, I do need to return the total. Very good. And then, yes, we're missing all the rest of the patterns. Panic, bad pattern. S pos dot dot pos plus 3. And then we're not using instructions. That would have been nice to be able to do that. But that test passes. So that means this bit works. Let's run it on the real input. Unsolved. Oops, I didn't run it on the real input. Okay, we have to just basically do this line here. Except instead of process, it's process conditional. And we get a different number. And it's smaller, which you would expect, right? Oh, it's too high. All right, what did I do wrong? The do and don't could be corrupted, but I'm only finding it if it actually exists. Right? It has to be do and apostrophe t open paren close paren, or the find won't find it. I wonder if it needs to preserve across lines. I wonder if there's like a don't at the end of a line. Wow, that's Christmassy. Let's find out if do open paren close. Oh, yeah. So there's a do. I see a do here. Don't. Yeah, there's a don't here that we don't redo until the next do, wherever that is, which looks like it's right here. Okay, so we just have to remember it. Oops, I didn't mean to quit. So it's not per line. What's the easiest way to do this? Okay, maybe this is cheating, but I can do it this way. Let s equals self lines iter collect string. And then we just say process we can't do that because it can't be built from a reference to a string. Copied. Nope. Cloned. Okay, it's a smaller number. It's cheating though, I think. Yeah, that's the right answer. Okay, so that was the problem. It was because if once you hit a don't and then hit end of line, you have to continue with the don'ts, and I wasn't doing that.